Okay. All right. This is the recap. Pay attention, especially the people that don't know how to do this. We're just going to recap how we came up with the two formulas for arithmetic series, finding the sum of a certain number of terms in an arithmetic series, or finding the sum of a geometric series. All right? So some of you who weren't here on the day we did arithmetic, this might be useful. Some of you who weren't here on the day we did geometric, or you just weren't listening, this will be useful. So, who remembers how slick we were with something like this? 1 plus 5 plus, what do you think the next one is? Why do you keep saying no? Matt, plus, you know what I'm saying? Who wants to pick the last term of this one? Or do we make it infinite? You want to make it infinite? But what if I said to you, I want you to find the sum of the first, Athena, pick a number. The first 13 terms, okay? You would need to know what? Well, if you don't know the formula, you would need to know the last term, or the 13th term. But if you do know the formula, you don't even need that last term. So which term would we want to know if we don't know the formula? T, you already know T1, it's there. T13, right? So what would T13 be? Well, if you wanted to find it, you could just think about this. Did y'all say arithmetic or geometric? It's arithmetic. Does anyone know what the 13th term is? Could you find it real quick? Or? It's take the first term, add to the first term the common difference how many times? It would be 12, but if you wanted to be more general about it, n minus 1, right? That's the general term formula. So you would take the first term and you would add the common difference 12 times if you're looking for T13. Know what I'm saying? So what's the common difference? Okay, and then you're going to take 4 and multiply it by 12, so 48, plus 1, 49. Okay, so again, we're assuming we don't know the formula for an arithmetic series. So what was the slick trick we used to find the formula? Yes, Athena. Yep. You're going to add it to 1. Okay, so what she's essentially saying is if you take that same series and write it backwards, well, what's the term that comes before 49? 44? Before 44? 40? And what pairs up? Or sorry, no, 44 is not right. It's not 44. It's 45. What's wrong with y'all? Then it's 41. You know what I'm saying? Dot, dot, dot. What's the last term? Which is actually the first term. What do you notice about all those pairs of numbers? They all add up to 50, right? Well, you don't have to bother doing all of these because when you took the first term and the last term, it gives you that number, 50. So, Athena, you were saying take that number, 50, and multiply it by what? Multiply it by this number right there, and do what with it? And divide it by 2. So, to summarize what we did, to find S at n, or the sum of the first n terms, we take the first term. What do we call the first term? A or, and we take the last term. What do we call the last term? We add them, and then we multiply by, and then divide by 2. Y'all understand why that works? Do you guys get it? Because we wrote the list once, and then we wrote the list twice, and then we added them all together. What do you mean we added them all together? Well, we took 50, and we added it to 50, and we added it to 50, so it took care of all of these. How many times did we add 50? N times. But we have to divide by 2 because we have the list twice, and then that gives us the total. Y'all down? So that formula is good, but some of y'all prefer to use the letter A instead of T1, so we can replace that with A. And then if you like the letter A, maybe you want to replace Tn with something that has A in it. You know what I'm saying? Well, remember this? Hey, what just happened? Remember this? Just replace that Tn with A plus n minus 1 times D. So if we do that, A plus n minus 1 times D, and if we simplify all that, and don't forget the n over 2 out there, that ends up being 2a plus n minus 1 times d. You can write n minus 1 times d or d times n minus 1. It's all the same. I'm going to write the n over 2 over here. Again, that doesn't really matter. That was the formula. Pretty easy, right? Cool. You had a question? Sorry, what? Why two lists show up when you multiply 13 by 50? Okay, there was not 2 lists, there was 1 list. But the trick is, if I take that same list and I write it a second time backwards, so here I go writing it backwards, 49, 45, 41. Well, if I write the second list and I add all the numbers in both lists, I'm getting twice the number I'm looking for. Do you understand that? Well, if I add all the numbers in the list, I get the answer I want. If I add all the numbers in the list and then I add all the numbers in the list again, that's the list twice. Agreed? So that I can use the shortcut. Because I don't want to go 1 plus 5 plus 9 plus 13 plus 17. I want to use the shortcut, and the shortcut is when I take the first and the last term, I always get the same number as if I were to add the other pairs. They all add up to 50 in this case. You understand? So now I can just go 50 times 13 terms, divide by 2, and there's my answer. That was quick. As opposed to 1 plus 5 plus 9 plus 13. We good? Okay, so that was the shortcut for arithmetic. Let's do geometric. This one here is not so easy. Does anyone remember how to find the sum of geometric series? Well, let's start with this. If I wanted the sum of a geometric series, what do I call the first term? So I'm going to go A, and then, sorry, let me do this. A, and then what am I going to add to A? No. A is the first term. No. Thank you. I'm going to add to the first term the second term, which is AR. What do I add after that, David? Good. Which is considered the third term. Good. Dot, dot, dot. What's the last term I'm going to add? ARN minus 1. Thank you. Well, if there are 10 terms that you're going to add together, it would be finding S10, right? The first term is A. See, there's no R there. So if I do this, I'm going to have AR1, AR2. The last term is going to be AR9, right? Not 10. We good? Cool. So If you want to do it the long way, this is what you do. You have to find every term and then add them all together. So if I say find S150, have fun. Enjoy your weekend. Because that's how long it's going to take you. What's up? R stands for the common ratio. So in a geometric series, it's the number you keep multiplying by. You understand? Okay. So, do y'all want to use this technique, the sippy cup technique? Nuh-uh. Which technique you want to use? Psst, there we go. Yeah. So, how are we going to own this? What are we going to do? Are we going to write the series backwards and then add them and divide by 2 and multiply by n? No, that's still arithmetic. Yes? You lost me at times. Sometimes it's okay to use the word times. Not this time. This is not that time. Don't be that guy. Say it again. Oh, seriously? You don't know another word for timesing? Thank you. So you what? See how he just grew up? Like 10 years right there? Yeah. Put your fruit roll up away, guy. Yeah. We're about Pop Rocks here. Pop Rocks. You know what Pop Rocks are, right? You ever put Pop Rocks in your nose? No, me neither. Me neither, but I had a kid in one of my classes last semester that told me they did. I didn't believe him, but that would be next level. Probably not enjoyable. I don't know. Depends on the flavor. It'd be crazy. Hey, don't do that, okay? I did not tell you to put Pop Rocks in your nose. I asked you if you put, just like my first year teaching, I had a kid stick a nickel in their nose. In English class, we were doing Romeo and Juliet. And it got stuck. Yeah, I didn't want to be. Sometimes they give you stuff. I had a grade 7 class for French, for religion, for math, grade 11 chemistry, grade 11 math, and grade 10 English. Not English. Tell you what. And not grade 7. Tell you what. Okay, so what did you say, guy? Okay, so if I go and I'm going to rewrite the whole thing again. Y'all ready for this? Just watch. This is going to blow your mind. What am I doing? I just wrote it twice, didn't I? That's okay. But now I'm going to do what he said, which is multiply by r. So that means everything to the right gets multiplied by. Okay, so AR squared, AR cubed, AR. This will just be to the power n. You know what I'm saying? N minus 1 plus 1. So A times r to the n minus 1 plus 1 is just A times r to the power of n. Y'all down with that? Okay. Why are we doing this? We're doing this so we can come up with a shortcut and we can come up with a formula so we don't have to add all the terms and find all the terms. So what can we do? What do you notice about the two lists that I've written? Jim, what do you notice? Diego, what do you notice? Yeah, okay, so but I multiplied Sn by r, which means I have to multiply everything on the other side by r. It's all about BS, right? Well, we did it. Okay, now what do you notice, though, about my two lists? Yes? What do you mean by cancel? You're getting ahead of us here? You're on the right track, but what? Just by looking at the list, what do you notice? And I even lined them up. Do they share anything in common? Would you say they share many things? So if they have a lot of the same things, what can we do to eliminate most of that list so that our list is very small? We don't have to do many operations. Chloe? So if I go and I subtract one from the other, so let's say I subtract the orig from the R guy, well, these are going to annihilate each other. So are these. So are all the rest of these, except not the last one, and not the, not the last one here, not the first one there. So when I subtract, I'm going to get RSN minus SN. That's the left side. What do I get on the right side? Remember, it's top. And when I say minus, in this instance, that's good because I'm not using it as a verb, right? I'm not conjugating, I'm minusing. And that minus that is, so what's that and what's the other that? This minus that, what is my this and what is my that? Okay, shorten that up because we don't need to say all that gibberish. AR what? AR to the power what? Straight up N. Everybody agree with that? So this right here is AR to the power N. And then what else do we have? That's basically the formula. We just need to clean it up so that it looks like this. SN is all alone. So how do we do that? What do you think, Julia? Yeah, a little bit of factoring. Chloe, you have a question? Yeah? Well, that wasn't the original. The original was just SN. Okay, yeah. Okay, so what I'm doing is the top equation minus the bottom equation, right? So I do this minus that. And then on the right side, I do all of this minus all of that. Okay, but you said you know, but I don't think you understood what I was trying to highlight here. So when I say take all of this and subtract all of that from it, do you remember when we said a bunch of them match up? So all the ones that match up disappear. So then you're left with, it's the top minus the bottom, right? I just took the original one and I multiplied it by R. No problem. I misunderstood your question. Sorry. Okay, so y'all down? So we're going to do a little factoring on the left side. What can y'all factor? SN. I'm going to factor out SN. What's left? Boom. On the right side, what can I factor out? A. Leaves me with Rn minus 1. Yes? Now what can I do to both sides so that I end with Sn equals? Boom. And what are we not going to do at this point? Correct. Because they're not common factors, yo. Okay? So there's our formula. Are we good? That's geometric. That's arithmetic. Somewhere. R to the power n minus 1 over r minus 1. Yes. Rhea, did you have a question? Good. What's up? Yep. Okay, let me pull it up. Hold on a second. A whole new world for me and me. Okay. I thought I had the textbook open, but I don't. I'm just going to open it. Where is My Hypera. I don't see it. Let me close. Whoa, whoa, whoa! Bite your tongue, children. Y'all should check that lesson out, the math lesson that you missed there, Wonderland kids, because we candled the eggs, and that was pretty awesome. Say that again? Do you guys remember if KFC was one of the ones that didn't make it? I didn't mention it, so I think we're good with KFC. They are egging, yo. Okay. Yeah, I guess I must have closed the Hypera. Do you guys see my Hypera tab? It's usually there. I must have closed it. I have a Google what? Oh, here. Oh, here, I'll just go Hypera like this. Oh, that's not what I wanted to do. I wanted this. Okay, what page number, Chloe? 459. Way down. How's that?
Yeah, you might stand on it because there's no nerves in there. Yeah. Like that's what I heard. Just get
All right. Listen up, kids. If you are a student that has access to resource, then you need to sign up for your exams so that you can write in resource. And what you can do is between now and the end of class, go up to resource and you can sign up. But I'm going to ask you to maybe go after we take up this question and do your quiz. What's the 459 you said? Okay, what's the question number? Shh. 4C? Okay, determine whether each series is arithmetic, geometric, or neither. And if it's geometric, do your thing. So if I look at C, you're going to take the second term and subtract from it the first term, and then you're going to repeat with the third term minus the second term. And if you don't have the same number, you know it's not arithmetic. If you want to know whether it's geometric or not, you're going to divide. So I'll go negative 512 divided by 2048, and I get negative 0.25. So now I'm going to go 128 divided by 512, and I get negative 0.25. So it's geometric. Does that make sense? Yeah. Well, if it alternates, if your terms alternate between adding and subtracting, it usually means you're multiplying by a common ratio that happens to be a negative number. Is that good? Good? So what you're actually adding the numbers in the sequence or in the series, but because the common ratio is negative, the number keeps changing from positive to negative to positive to negative. Right. If you have alternating signs like that, it's not arithmetic, that's for sure. It might be geometric though. So neither means you don't have a common difference, nor do you have a common ratio. So you do both tests. And neither of them work, so we good? All right. As promised, I'm going to give you your quiz. I told y'all. Right now.
I was not ready for that.
I tried to prepare you by telling you yesterday.
You didn't tell us. You did not tell us.
You said we're gonna have a quiz. You said we're gonna have a quiz, so not this.
You said no. Listen. How many times did I tell you guys that you should be ready for quizzes basically any time? And then I've given you how many really easy quizzes that take like 2 minutes, right? And you guys treat a quiz like it's a test. You need to grade 11 it up. Right now you guys are acting like If you don't think I mentioned this yesterday, you weren't listening. Because half the class acknowledges that I told you about this yesterday. I didn't specify it was going to be today, but I was insinuating it was going to be today. And I bet you half of the class could tell us what it